Hello, and the purpose of the day is I can solve quadratic equations by graphing to find their roots. Let's clarify a little bit more about range. So if you have a minimum for your quadratic and a parabola, you know that your parabola will open upward. Therefore, your range will be in the form of any number is less than or equal to y, which is less than infinity. That will always be the range if you have a parabola that opens upward. So let's say that the minimum here was at negative 42. So that was the minimum. Therefore, I would write the range as negative 42 is less than or equal to y, which is less than infinity. However, if you have a maximum, we know now that the parabola will open downward, and again we'll have a maximum because that will be our highest point, and that will be in the form of negative infinity is less than y, which is less than or equal to the number that is your maximum. So let's say our maximum was 8. Then our range would be written as negative infinity is less than y, which is less than or equal to 8. I hope this clarifies a little bit more about the range of quadratics. Now we are going to look at solving quadratic equations by graphing. And solutions to quadratics, when we solve these, they're called solutions or x-intercepts or roots or zeros. You can use all four of those words interchangeably and they all mean the same thing. Again, that's solutions or x-intercepts. Again, this will be because our parabola will cross the x-axis and that will at an x-intercept, which is a solution, also called roots or called zeros of that equation. So you have three options for quadratic functions for their solutions, and we're going to look at three different types of graphs. Let's look a little bit closer. If I have two unique real solutions to a quadratic equation, that means my parabola crosses the x-axis 2 times. And I can have two different versions of what my graph looks like. One, the parabola could open upward, like this. And as you can see, I cross the x-axis 2 times. One would be right there, and the other would be right there. Hence, I have two solutions. Or my parabola could also open downward. And again, it doesn't matter where my parabola is, I just have to cross the x-axis 2 times to have two unique real solutions. So that would be two different types of graphs that you could see if you have two real solutions. Or you could see one unique real solution. So now your parabola is only going to cross your x-axis 1 time. So what this looks like is my parabola could open downward, so like this, and that intersection at the x-axis would be 1 time right there. Or my parabola could open upward, and I'll still cross the x-axis 1 time. So let's see here. That doesn't look like it crosses. Neither does that one. Or that one. There we go. Okay, so, and then that one solution would be right there. And again, we have one solution because our parabola crosses the x-axis 1 time. Or we could even have no real solutions. And how many times do you think the parabola will cross the x-axis here? You are correct, 0 times. So again, our parabola could open downward, and we don't cross the x-axis at all, or it could even open upward, and it just never crosses the x-axis, so no solution. Okay, let's look at an example for what two unique real solutions would look like. So again, we're going to solve by graphing, and we're going to graph x squared minus 3x minus 10 equals 0. So we're given an equation, and it's already said equal to 0, so let's try factoring to find our actual solutions to this quadratic equation. So I am going to use the diamond method, again, because I have a 1 in front of x squared, so I can use a diamond method, and I'm going to say factors of negative 10, that when added together give me negative 3, and good job, you guessed it, which is negative 5 and 2, so I'm going to set x minus 5 and x plus 2 equal to 0, and my two solutions are 5 and negative 2. So I'm going to go to my graph right now and I'm going to plot those two solutions, and again, those solutions are where your parabola crosses the x-axis. Okay, now we need a little bit more information still here to graph this quadratic. So I'm going to find the vertex. And again, to find the vertex, that is opposite of b over 2a for the x-coordinate. Then I'm going to plug that in to find the y-coordinate. So here, x equals opposite of b here would be opposite of -3, which is +3 over 2 times a, which is 1, which here is 3/2. And now I'm going to go ahead and plug in 3/2 to find the y-coordinate. Okay, so here I have 3/2 squared minus 3 times 3/2 minus 10, and 3/2 squared is 9/4, minus 3 times 3/2 is 9/2, and then minus 10, which will give me -12.25. So my vertex here is 3/2 -12.25. And I'm going to go ahead and plot that on my graph right now. My vertex is plotted, and it's actually off my graph a little bit, but I did my best to estimate where it is. Now the last piece of information before we graph is I'm going to find the y-intercept. And again, the y-intercept can be found by figuring out what c is. So in the form of 0, c. And here, what is c? It's -10. So my y-intercept here is going to be -10. So that's in the form of 0, -10. And I'm going to go ahead and plot that right now. Okay, I've plotted the y-intercept at -10 in purple. Now I'm going to connect my points with a smooth curve here and get my parabola graph. So I'm going to do that right now. So I've connected my vertex with my y-intercept and my two solutions. So I'll write those in here underneath my graph. So solutions are x equals 5 and -2. And again, we found those by factoring. So we just solved this quadratic equation by factoring and graphing. So you can tell by looking at the graph that we have two solutions, and we know exactly where those two solutions are because we were able to factor, which they were at 5 and -2. So again, here is an example where we had two unique real solutions. Let's take a look at an example when we have one unique real solution. So we're going to solve by graphing x squared plus 8x equals -16. And again, to help us out, to try and figure out where exactly the solutions are, let's try factoring. But in order to factor, I need everything equal to 0. So I'm going to move over this -16 to the other side, and I'm going to get x squared plus 8x plus 16 equals 0. Now I'm going to factor by using the diamond method, again because there's a 1 in front of x squared. And really, if you look a little bit closer, this is a perfect square trinomial because I can take the square root of my first term, which is x, times the square root of my last term, which is 4, times 2, and that equals 8x. But just to show a little bit more, I'll go ahead and factor. So factors of 16 that when added together give me 8 are +4 and +4. So I get x plus 4 times x plus 4 equals 0. So what are my solutions here? Well, I'm just going to get x equals -4 twice, and I don't need to write it twice. I can only write it once if I want to. So my solution is x equals -4. So I'm going to write that in here right now, and I'm actually going to go to my graph, and I'm going to graph this solution right now. Now before we can fully graph this, let's go ahead and find the vertex. So again, to find the vertex, I need to take opposite of b over 2a to find the x-coordinate, then plug that in to find the y-coordinate. So here, opposite of 8 would be -8 over 2 times a would be 1, which is -8 over 2, which is -4 for my x term. So if I plug -4 in, I'm going to get -4 squared plus 8 times -4 plus 16, and that gives me here -4 squared is 16 minus 32 plus 16, which equals 0. So my vertex is -4, 0, and if I plot that, that's actually where that one solution is right now. Okay, let's keep going. Let's look at the y-intercept. The y-intercept is in the form of 0, c. So 16 here is c. So 0, 16 is my y-intercept. I'm going to go to my graph and graph that right now. And my y-intercept actually goes off on my graph because 16 is higher than what my graph allows me to graph, but I estimated and did my best. Now I'm going to connect with a smooth curve, my vertex, with my y-intercept. And again, I know my parabola should open upward because 1 is in front of x squared, which is greater than 1. So I'm going to go ahead and connect and make my parabola. And then I notice that my parabola crosses the x-axis one time, so I have one solution, which is actually where my vertex is, and that is at -4. So again, here was an example where we had one unique real solution to a quadratic equation, and we used factoring and graphing to help us solve. Okay, now let's take a look at when we may have no real solutions to a quadratic equation and see what that graph would look like. So I'm going to look at my equation and I see x squared plus 2x plus 3 equals 0. So let's try factoring to solve. And again, I'm going to use the diamond method because I have a 1 in front of x squared here. So factors of 3 that when added together give me 2. Factors of 3 are only 3 and 1, but I need to get a positive 3 and they need to add up to be 2. So there actually are no factors that will work. Okay, so I can't solve for any right now with factoring. So let's go ahead and let's just try to graph this equation by finding the vertex and the y-intercept. And then we'll have the axis of symmetry as well and just connect the points with a smooth curve. So let's look at here the vertex. And I'm going to figure that out by finding opposite of b over 2a, which would be -2 over 2 times 1, which equals -2 over 2, which equals -1. I'm going to go ahead and plug that into my equation to find my y-coordinate. So -1 squared plus 2 times -1 plus 3 gives me 2. So my vertex is -1, 2, and I'm going to go ahead and plot that right now. So on my graph, I plotted the vertex at -1, 2 in purple, and I also in green drew that in the axis of symmetry, just because we haven't talked about that in a while, but again, that goes right through the vertex, and we'll cut the parabola exactly in half. All right, let's find the y-intercept here. The y-intercept is going to be whatever c is, and in this case here, it is going to be 3, so my y-intercept is at 0, 3. I'm going to go graph that right now. I've graphed my y-intercept in orange. Now I'm going to connect my vertex and my y-intercept with a smooth curve to make my parabola, and I know that my parabola should open upward because 1 is in front of x squared, which again is greater than 0. So I'm going to go ahead and connect and make my parabola right now. So I've drawn in my parabola, and I see that my graph does not cross the x-axis at any point. And again, we couldn't factor, so that should have been a hint. When you couldn't factor, there would be no solutions. So down here under the graph, when it says solution, I'm going to write no solution because this parabola does not cross the x-axis. Please feel free to add this problem to your notes. We were going to go over this example in class tomorrow, but to be ahead, if you want to jot down this question to number 4, that'd be a great idea. Thanks for listening. Have a great day. Bye-bye.